Okay, so we've done our review of whole numbers and number systems and stuff. Today we're going to jump into some of our material for the course. This is going to feel a little bit like review yet, but this is actually very important that we understand completely how these work. So today we're going to talk about one more type of number. Everybody's favorite type of number, fractions. Yeah, I know, I heard the groans. If I asked people on their way in the door what they hated most about math, 4 out of 5 students would say fractions. But fractions kind of get a bad reputation because they're presented as a totally different animal. It's not shown how they actually connect and follow the same rules as everything else. So let's take a look here at a fraction. The top number of a fraction, as we said, was called the numerator. And the bottom number is called denominator. And we discussed how that top number, the numerator, is a count. It tells us how many we have. We have 3 of something here. And that bottom number is a name. Just like having cows or inches or pounds or whatever, here the fourths are telling us what it is we have. We have 3 of them, and they're fourths. So before we do too much more, let's illustrate what it means to be 3/4. Well, I'm going to go back to the old elementary school representation. Pretend that looks like a circle. And think of like a pie or a pizza. Fourths, the name of fourths means that it's cut into 4 equal pieces. Pretend those are equal. The 3 then means, so what the 4 means is that whole object is cut into 4 equal pieces, or you can think of it as it takes 4 of those pieces to make one whole object. Either way works logically. So now we have 3 of them. So that means that out of those 4 pieces it takes to make a whole object, we do have 3 of them. And we've all seen this illustration of 3/4 before, so I'm not showing you anything new. But as we discussed back on the first day, you might run into problems like this: 3/4 plus 1/5. And remember our rule for addition and subtraction, we can only combine numbers that have the same name. Right now, this is fourths and this is fifths. We cannot combine those as they're written. So we're going to have to change their names to combine them. So the first thing we need to look at is how do we change the name of a fraction? Well, looking at this picture, probably the easiest way to change their names is to take every slice here, and we're going to cut them each one into 3 equal slices. Pretend these are equal cuts. So now, instead of 3/4, how many pieces does it take to make a whole object now? How many are there? $12, perfect. There were 4. Each of them got cut into 3 pieces, so now there's 4 times 3 or 12. How many slices do we have in yellow? 9, perfect. We had 3. Each of them got cut into 3, so 3 times 3 is 9. Do we have any more or less than we did to begin with? No, we don't. That 9/12 is exactly the same amount as 3/4. It just looks different. So how is it that we were able to change its appearance, change the way it looks, without changing the value? Well, that comes down to what we did right here. That's 3/3. We multiplied by 3 on top and bottom. Technically, we multiplied by 3/3. This bottom 3 is saying it takes 3 pieces to make a whole object. The top 3 is saying we have 3 pieces. In other words, we have one whole object. So what we really did there was we multiplied by 1. And when we multiply by 1, we do not change the value. This concept is called the idea of a unity fraction. We use that in math a lot. In fact, in Unit 2, we're going to use it a lot when we start converting measurements. Now here we just picked the 3. We cut each of them into 3 equal pieces. So we just picked 3 to multiply the top and bottom by. In reality, there's going to be a specific name that we want to change the fraction to. For example, if we have 2/5, let's say we want that name to be 30/5. So what we have to do is we have to figure out what are we going to multiply this beginning fraction with. Well, we have to look at what do we multiply 5 by to get 35? 7. Good. So what do we have to do to the 2? Multiply by 7. We have to do the exact same thing to the top as we do to the bottom. So 2 times 7 makes 14. Again, 14 35ths is the exact same value as 2/5. We've just changed the appearance. So in your notes, I'm going to have you take 3/8. Tell me how many 40ths that would be quick. Perfect, 15 40ths. 8 times 5 to get 40. 3 times 5 to get 15. So again, 15 40ths and 3/8 are the exact same value. Now what if we want to go the other way? What if we want to get back to the 3/8? Well, we multiplied by 5 on top and bottom to get from 3/8 to 15 40ths. The reverse of that would be to divide by 5 on top and bottom. 15 divided by 5 is 3. 40 divided by 5 is 8. And we've already established that 15 over 40 is the same as 3/8. So we can, on any fraction, divide the top and bottom by the same number. It's called, bless you, called simplifying. So if I have a fraction like 18 30ths, and I ask you to simplify that, what we're doing is we're trying to find numbers that we can divide both the numerator and denominator by, both the top and bottom by. Now, we've always been told that we have to find the greatest common divisor, or the greatest common factor. We have to find that largest number that divides into both. That's not necessarily true. It's easiest if we find the largest one, but really we only have to find any number that divides into both. What's a number that divides into both 18 and 30? 3. I heard some people say 6, and that would work as well. 18 divided by 3 is 6. 30 divided by 3 is 10. Now we see that we can still divide by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. That works out just fine. Now a couple of you said 6. 6 is that largest common divisor. If we divide it by 6, 18 divided by 6 is 3. 30 divided by 6 is 5. So we get down to that 3/5. Finding the 6 just makes the process a little shorter. If you find that largest divisor or largest factor, it makes it a one-step process, one division. But you don't necessarily have to find that smallest or that largest one. You can do smaller factors, smaller common factors, and just go through a couple of steps. I'm going to have you guys reduce for me 48 over 60. So reduce that quick in your notes and see what you come up with. What'd you get? 4/5. Good. Now, there are a lot of ways we could have gone about that. Some of you may have seen that both of those can be divided by 12. 48 divided by 12 is 4. 60 divided by 12 is 5. But if you hadn't, I tend to go through a progression when I'm reducing fractions. I look to see if they're both divided by 10. Why would I look for 10s first? Why is it so easy to spot that they're divisible by 10? Yeah. If they are divisible by 10, they end in 0. So it's really easy to tell if they're divisible by 10. Next thing I look for is to see if they're divisible by 5. What would I be looking for there? Well, if their last digit is a 5 or a 0. So here I look at them. The 60 ends in a 0, so that's divisible by 10, but the 48 doesn't. So when I go to the 5s, I look, 48 still doesn't end in a 5, so I can't divide that one by 5 either. Next, I would look for 2. How do I know if a number is divisible by 2? Yeah, it's even. The last digit is even. Does it end with a 0, 2, 4, 6, or 8? Both of these are even, so I might divide both of them by 2. 48 divided by 2 is 24. 60 divided by 2 is 30. Well, I see they are still divisible by 2. 24 divided by 2 is 12. 30 divided by 2 is 15. Can't divide by 2 anymore. So then I would look for 3s. Does anybody know the shortcut to tell if a number is divisible by 3? It goes off the sum of the digits. Now we know just by looking at them that both 12 and 15 are divisible by 3. So let's do that quick and get it over with. 12 divided by 3 is 4. 15 divided by 3 is 5. So it's the 4/5. So yes, you guys were definitely correct with the 4/5. Well, let's look at that divisible by 3. So 2,835. Is it divisible by 3? Well, here's how you would tell. There's a shortcut for how you tell. Obviously, you try to divide it out and see if you get a decimal or fraction or whatever. But let's add together the digits. What's 2 plus 8? 10 plus 3? 13 plus 5 is 18. Is 18 divisible by 3? Yeah. So 2,835 is divisible by 3 as well. We might run into simplifying something like this. 44 over 7. Now, most of you know this is what we call an improper fraction. Improper implies there's something wrong with it. There isn't anything wrong with it. In fact, there are going to be times where we prefer to have a fraction in this form. We just don't like having it that way because what it's telling us here is it takes 7 pieces to make a whole object. And if we have 44 pieces, we not only have enough pieces to make a whole object, we have enough pieces to make several whole objects. And it's easier for us in many cases to visualize whole objects with pieces left over than it is to visualize that many pieces sitting there. So we're going to split this up into what's called a mixed number. In the mixed number, we have whole pieces or whole objects plus the pieces that are left over. Well, how do we figure out how many whole objects or whole numbers we can get out of 44 over 7? Well, we can take 44 divided by 7. Now, if you were to punch that in your calculator, it's going to give you something like 6.2857143 approximately. What's that telling us? Well, the 6 tells us we can get 6 whole objects out of this. The decimal tells us that we do have some pieces left over. Now, we don't necessarily know how many yet. So we have to figure out how many pieces were used up by the 6 whole objects. 6 objects times 7 pieces each is 42 pieces. So out of 44, how many pieces are left? We've used up 42. Out of 44, we have 2 left. So that is 6 2/7. Basically what that is a division and remainder. 44 divided by 7. 7 goes into 44 6 times. 6 times 7 is 42. There's 2 left over. So the 2 stays in the fraction, 2/7. Have you guys do 1 in your notes? 38/5. See what you come up with there quick. So go for it. What'd you come up with? 7 3/5. Good. 38 divided by 7. 5 goes into 38 7 times. So 38 divided by 5, I should say. 5 goes into 38 7 times. 7 times 5 is 35 with 3 left over. So 7 3/5. Excuse me. Sometimes we want to be able to go the other direction. So what if I have this 7 3/5 and I want to get back to that 38/5? Well, I have to break my 7 whole objects back into pieces. How many pieces do each of them have? 5. The denominator tells us how many pieces. So we do 7 times 5 is 35. And we add that back to our numerator of 3. 3 plus 35 is 38/5, which is back to where we started. Okay, so now let's start back to doing some operations with our fractions. We had 3/4 plus 1/5. We've gone through all this renaming so we can rename our fractions in a bunch of different ways if we need to. I'm going to rewrite this as 3/4, 1/5. I like to add vertically just because that's how my mind works. And we're going to have to find that common denominator, that same name. The first step is to figure out what that common denominator is going to be. And there are a few different ways we can go about that. One of them is to make lists. So I got 4 and I got 5. I might take, counting up by 5s, of course, is just 5, 10, 15, 20, 25, and so on. That one's easy. We would count up by 4s. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. There's our first match. That is our least common denominator, is 20. Another thing you can always do is you always just do 4 times 5. In this case, that gives us 20, which is our least common denominator. Now, kind of like simplifying the fractions, we've always been told you have to find the least common denominator. Once again, that isn't really true. You can use any common denominator. It's just the least one is the least amount of work. So if you find that smallest common denominator, it makes life a little bit easier for you. So anyway, we've got that least common denominator. And there are other ways of finding it using factoring, all sorts of other things as well. For now, I'm going to assume you guys can find the common denominator. So the common denominator of 20, 3/4 is going to become how many 20ths? 15, good. It was 4 times 5 to make 20, so it has to be 3 times 5 to make 15. 1/5 becomes how many 20ths? 4, good. 5 times 4, so 1 times 4. So 15 plus 4 is 19 20ths. I'm not going to waste any more time on simple fractions for addition. We're going to jump up to mixed numbers. So 16 1/5 plus 12 5/8. Just like any other fraction, we still need to find our common denominator, which is going to be what here? Heard somebody mumble it there, 40. What's this going to become up here? 8/40. Good. How about here? 25. Now you can see I've got those fractions written at the end of the number, kind of like they're the last digit of the number. And in fact, that's what they are. The fraction is just the last digit of our number. We're going to add, subtract, just like any other number. We're going to start on the right and work our way back to the left. So we start with the fraction, 8/40 and 25/40. Combining the counts, 8 and 25 make 33. Keeping the name of 40. 6 and 2 makes 8. 1 and 1 makes 2. So we have 28 and 33/40. It doesn't stay that simple, of course. We run into things like this. 37 3/4 plus 26 5/6. What's our common denominator going to be? 12. Very good. What's this going to be up here? 9. And this one? 10. Good. When we go to add, we're still starting on the right, working right back to the left. We do 9/12 and 10/12 make 19/12. Now that's an improper fraction. So we're going to have to break it back down. 12 goes into 19 once, with how many 12ths left over? 7, right? 12 out of 19 leaves us with 7. So just like any other number, we're going to keep part of it and carry part of it. So I'm going to keep the 7/12 here. The fraction part stays in the fraction digit. And I'm going to carry the 1 into the ones digit. 1 and 7 makes 8. Plus 6 is 14. So 4 carry the 1. 1 and 3 is 4. Plus 2 is 6. So 64 and 7/12. Let's look at subtraction. We're going to start in on subtraction with mixed numbers as well. We're not going to spend a lot of time dealing with simple fractions. So let's look at 19 and 3/5 minus 11 and 1/3. And just like addition, we need a common denominator, which is going to be 15. Good. This is going to be 9. And this one? 5. Good. So now when we subtract, 9/15 minus 5/15 is 4/15. 9 minus 1 is 8. 1 minus 1 cancels out. So 8 and 4/15. Now again, it doesn't stay that simple, of course. We can run into things like 8 and 1/4 minus 5 and, let's do 3/5. What's our common denominator? 20. What's this numerator? 5. And this one? 12. Okay, so now we go to subtract. 5/20 minus 12/20 gives us a problem. We can't take 12 away from 5. So we're going to have to borrow, make the 8 a 7. What is this going to become? Careful, very careful. What I borrowed there was 1. The denominator tells us how many pieces are in that 1. That 1 that we borrowed from the 8 has to have 20 pieces in it. So we're going to add 20 to our 5 to get 25/20. Now, if you think about it, and I asked that, I was hoping somebody would say that you just put the 1 in front of the 5 and make a 15. If you think about that, 15/20 is still less than 1. We have to have something bigger than 1 because we borrowed 1 from the 8. So now 25/20 minus 12/20. 25 minus 12 is 13. 7 minus 5 is 2. Let's do one more example of the borrowing. Let's do 39 1/8 minus 19 5/6. Common denominator. I'll help you out. There's 24. What's going to go up here? Careful. I know what you're thinking. It's 3, right? 8 times 3 and 1 times 3. What's going to go up here? That's okay. Happens to the best of us. What's going to go up here? Six times 4, so 5 times 4 is 20. Good. So again, we go to subtract. 3 minus 20 can't be done, so we borrow. This is an 8. What's this become? What do we have to add to the 3? 24. We have to add the denominator. So 3 plus 24 is 27. So now it's 27 minus 20 is 7 24s. 8 minus 9, we're still going to have to borrow. So this will be 2 and 18. 18 minus 9 is 9. 2 minus 1 is 1. So 19 and 7 24s. Let's move on to multiplication. I'm going to change this just a little bit. We'll do 2/5 times 1/4. So when I multiply, as we looked at on the first day, when we multiply, we combine the counts. 2 times 1 is 2. And we also combine the names. 5 times 4 is 20. Because of that, we did not need to have the same name. We did not need common denominators. So when we multiply, we just do that multiplication straight across without worrying about common denominators or getting the same name. Now, some of you, when we look at this, we got 2/20. What can we still do with that? We can reduce it. Both of those can divide by 2 to give me 1/10. Some of you might be looking at this original problem wondering, well, why didn't he cross cancel or cross multiply, depending on what you've been taught as the terminology for it. Some of you right now might be wondering, well, what's cross canceling? Well, if we look at this, the top is going to become 2 times 1. The bottom is going to become 5 times 4. You might see that both the 2 and the 4 can be divided by 2. So I can actually do that before we multiply. I can take 2 divided by 2 is 1. 4 divided by 2 is 2. And now when I multiply, I have 1 times 1 is 1. 5 times 2 is 10. I've reduced it before we multiply. In a problem like this one, it's about the same effort either way. But I can run into problems like this. Like 24 25ths times 35 36. I could multiply this out. And 24 times 35 is what? 840? And 25 times 36 is 900. And I'm sure all of you can see by looking at that both of those can be divided by 60, right? Obviously, probably divide by 10, then by 3, and then by 2, right? But you would get down to, if you reduce it down, you get down to 14/15. Well, I don't like working with large numbers like that because there's more apt to make a mistake. It'd be nice to reduce this down before we multiply, and I can do that. 24 and 36 both can be divided by what? They can both be divided by 6. Very good. 24 divided by 6 is 4. 6 divided by 6, or 36 divided by 6? 6. I don't know why I wrote 6 up there. I said 4. Thank you. So 24 divided by 6 is 4. 36 divided by 6 is 6. Now looking at those, I see that 6 and 4 can both still be divided by 2. So 4 divided by 2 is 2. 6 divided by 2? 3. Now I can't reduce that anymore. But I can still divide out the 25 and the 35. Both of them divide by 5. 25 divided by 5? 5. 35 divided by 5? 7. Now I see 2 times 7 is 14. 5 times 3 is 15. That one to me is less work if I reduce it before I multiply. Now again, I'm not going to waste a lot of time with simple fractions for multiplication. I'm going to go back right up to mixed numbers. So let's do something like 5 and 1/4 plus 7 and 1/3. Not plus, times 7 and 1/3, I should say. Multiplying mixed numbers is actually an extremely difficult process. In fact, if you were to go to any UW school and find 10 math majors, I would actually be surprised if even 1 out of the 10 could show you the correct process for multiplying mixed numbers. So how are we going to do it? We're going to multiply those. Well, how are we going to make this manageable? Well, we're going to cheat. We're going to turn them into improper fractions. 5 and 1/4 becomes how many fourths? 21 fourths. Good. 7 and 1/3? 22 thirds. Good. Now that these are fractions, we can cross cancel just like any other fraction. So here I see that 21 and 3 can both be divided by 3. 21 divided by 3 is 7. 3 divided by 3 is 1. Anything else? 2. Perfect. 4 and 22 can be divided by 2. 4 divided by 2? 2. 22 divided by 2? 11. Good. So now 7 times 11 is 77. 2 times 1 is 2. If I divide that out, 77 divided by 2. 2 goes into 7 3 times. That's 6 with 1 left over. Bring down the 7. 2 goes into 17. 8. That's 16 with 1 left over. So that's 38 and a half. Just for fun, let's take a peek at how we would multiply those as mixed numbers. It works off the same concept as if we have something like, 26 times 34, I have to do this 4 times the 6, but I also have to do 4 times that too, right? Same thing here. I have to do 1/3 times the 1/4, but I also have to do 1/3 times 5. So let's start out. 1/3 times 1/4 is 1/12. How do I do 1/3 times 5? How do I do a fraction times a whole number? I put it over 1, so it's 5 over 1. So 1 times 5 is 5, 3 times 1 is 3, 5/3 or 1 2/3. Now I'm done with the 1/3, I go to the 7. 7 times 1/4. I make that 7 over 1 times 1 over 4, 7 over 4 or 1 3/4. And then I have 7 times the 5, which is 35. Now I have to combine all of this. And to do that, I need a common denominator. Looks like 12s are going to do it. So 1/12 is going to stay 1/12. The 1 2/3, well, 2/3 is 8/12. 1 3/4, well, 3/4 is 9/12. And the 35 doesn't have a fraction. 1 8 is 9, plus 9 is 18. 18/12 reduces to 1.5. So I keep my 1/2, I carry my 1. 1 and 1 is 2, plus 1 is 3, plus 5 is 8, and my 3, 38.5. I get the same answer. Now, I don't know about you, this process is a little tiring for me. I think I will stick with turning them into improper fractions. Let's do one more example of that quick before we move on to division. Let's do 3 1/8 times 2 4/5. Tell me what to do. What's going to go here? Try to contain yourselves and take turns. How many eighths? 25 eighths. There we go. Good. 3 times 8 is 24, plus 1 is 25 eighths. What's going to go here? 14/5. Good. Okay. Now at this point we can cross cancel. What can we cross cancel? So we get 1 and 5. Very good. What else? 14 and 8 gives us 7 and 4. So we multiply. 5 times 7 is 35. 4 times 1 is 4. That is 8 3/4. Let's do division. We said that division follows the same rules as multiplication. When we multiply, we just multiply straight across. Does that mean I can just divide straight across? Can I do 12 divided by 4 is 3? 25 divided by 5 is 5? Does that work? Say yes. It does. Is that the right answer? It actually is. So why don't we do it that way I mean, that looks a lot easier than some of what we've been taught. Well, the reason we don't do it that way is because we run into problems like this. 3/4 divided by 2/3. If I tried to just divide straight across, it just doesn't work out. 3 divided by 2 is like 1.5. And 4 divided by 3 is either 1.33333 or 1 1/3, however you want to look at it. So it's going to get to be an ugly number. What have we been taught to do to divide those fractions like that? Multiply by the reciprocal. So the first fraction doesn't change. It stays 3/4. We change it to times. The reciprocal of 2/3 is 3/2. So now it's just 3 times 3 is 9. 4 times 2 is 8. 9 eighths or 1 1/8. Well, believe it or not, this process of multiplying by a reciprocal comes from what I did up here. Let me just take a minute to show you how. Years ago, or once upon a time, if we had 3/4 divided by 2/3, what we would have done, we'd have looked at the number we're dividing by. First thing we would have done is we'd have made sure it's reduced. Well, 2/3 is as reduced as it can get. So that's reduced. And then what I'd do is I'd take the numerator times the denominator. 2 times 3 is 6. So then after that, I'm going to rename this first fraction using that number. So I'm going to take my 3/4 and I'm going to multiply by 6 on top and bottom. Then I'm going to divide by the 2/3. Well, 3 times 6 is 18. 4 times 6 is 24. Now, 18 divided by 2 is 9. 24 divided by 3 is 8. 9 eighths or 1 1/8. I get the same result. So you might still be thinking, this still doesn't look anything like that. Well, it's not as big of a leap from here to multiplying by reciprocal as you would think. At some point, someone was looking at this problem right here saying, we have 3/4, we're multiplying it by 6/6, and we're dividing by the 2/3. If we stretch our order of operations a little bit, And we do this division first. 6 divided by 2 is 3. 6 divided by 3 is 2. What we get here is always going to be this number just flipped over. So they gave it that name of a reciprocal, and then what's left is multiplication. So multiplying by a reciprocal is just a shortcut for this whole process I showed you here. Now, I don't expect you're going to start doing it the long way, but sometimes it's nice to see where things come from. So let's do one example of dividing mixed numbers. 5 1/2 divided by 2 1/3. So if I'm going to make this into multiplying by a reciprocal, it only makes sense I'm going to treat it just like I do with multiplication. I'm going to make them into improper fractions. 5 1/2, 5 times 2 is 10, plus 1 is 11 halves. 2 1/3, 2 times 3 is 6, plus 1 is 7/3. Now this is still division at this point. I'll put this out there. At this point, you cannot cross-cancel because it's division. You can only cross-cancel in multiplication. So the 11 over 2 doesn't change. It's the number after the division that goes with it. So it becomes multiplied by, reciprocal of 7 over 3 is 3 over 7. Now at this point, it's multiplication, and I could cross-cancel. However, there's nothing that cancels. So I'm going to go ahead and multiply. 11 times 3 is 33. 2 times 7 is 14. If I divide that out, that is 2 5/14. Okay, so some things that go along with our fractions that I want to make sure you're aware of. That cross-canceling is a very powerful tool. When we start looking at things like 8 milliliters per minute, and I'm going to multiply by 7 minutes. If I make that 7 minutes into a fraction, we can treat our units just like any other numbers when we cross-cancel. We can cross-cancel the minutes. So now it's 8 milliliters times 7 is 56 milliliters. So the units within our fractions can work just like any other number. It's what we call dimensional analysis. And it's a tool that we're going to use for doing our measurement conversions in Unit 2. And it's also a tool we're going to use for a lot of our dosage calculations in Unit 3. It's a very powerful tool in math. And it involves, not only does it involve the cancellation, cross-canceling, but it also involves some of those unity fractions we talked about. Okay, so we have about 1 more minute left in class. So just so that we don't get cut off, I want to give you the homework. It's going to be in the book on page 18 through 21, 1 through 97, the odds. Again, remember, I don't expect you to necessarily crank through 48 problems or 49 problems tonight. Look at them, look at the first ones, do 1 or 2 of the first ones. If they're really easy for you, move on to the next section, do some of the more difficult ones. Make sure you do, at the very least, do the more difficult ones at the end of the section so you know that you understand them. Also, don't forget that the solutions for the homework are posted on Blackboard in that course information spot. Okay, anybody have any questions? Bye, you guys have a great weekend.